Hello and welcome to Beyond the Hello World. Today let's create a grid. A grid is a generic two-dimensional container that can be accessible by two indexes that we'll call row and column. So yesterday we did something similar when we did our video of the tic-tac-toe. In that video we coded the game board as a vector that could be indexed by row and column. The issue is that it was specific for a 3x3 grid and it was not generic, meaning that it was only working for one type of data, charts. So let's start by creating a main file and also a grid.h. In the grid.h, I will create our class grid. So this class will have as private member the vector. We'll need to store how many rows and columns. Now, the vector, I didn't put a type. So if I had put a type char or int, the grid will not be generic. So let's do as a template. Now we have a generic grid. Let's create a constructor. Okay, just some clarifications about the constructor. Why in data we are constructing with columns times rows? A vector, a standard vector, this is a comment, standard vector. For example, I'll put a standard vector into my vector. There is a constructor that if I put 10 or I don't know 14 or 100, any number I'll put here will be the size of this vector. And it works for all type of vectors. I can put chars, I can put any type. This is the size. So this means that we are creating a vector. That data is creating a vector of size columns times rows. Okay, now why columns times rows? Because if we have a grid of n columns and n rows, we have the number of columns times the number of rows, like the area. How many elements do we have in the total? Something also for the constructor to keep in mind. In C++, if I put data, rows, and columns in this order, I need the constructor to be in this order. So I cannot change the order between columns and rows. The order here is not arbitrary, it's following this one here. After the constructor, we need a way to access each individual element. So let's create a reference at now, if I give row and column, I'm giving two indexes, but the vector is accessible by one index, meaning that I need to convert those two indexes in one index. We saw how to do this in the video of tic-tac-toe, but I went fast, so let me explain again. So now let's see how we can address an element. How can we index an element that from a one index container, like the vector, in a two index container, meaning that I want to get, for example, the element index 7. My index in row will be 1 and my index in column will be 2. So how do I translate from 1 and 2 to 7? We saw in the tic-tac-toe, what I need to do is just take the index of the row and multiply by how many columns do I have. So in this case, and add the columns. So in this case, I will have 1 times 5. There are 5 columns here, plus 2 gives me 7. Now, why this is the case? How many elements do I fit in one row? 5. Why 5? Because it's the number of elements in one column. So if I want the element index 7, I need to see how many rows do I have before 7. I have one row, right? One row fits 5. Then I have 2 other elements. So it's going to be my second row. I'm starting row index 1. By the way, index 1 means that I have one row before. Index 2 means I have 2 rows before. And the 0 means that I am the first one, the first row, so I have nothing before. So 7, I have how many rows before? How many full rows? Each row contains 5 elements, so I have one full row, so 5 elements. How many elements do I still need? 2. So this is going to be the index of the column. If I had, for example, index 17, we don't have in this draw, but 17, how many rows do I have before 17? I have 3 rows, right? 3 times 5, 15. How many elements do I still need to count? 2. How many index I still need to skip? 2. So it's going to be 3 index of row and 2 index of column. Another way of seeing this, it's thinking about the positional system. If I put, let me take a different brush. If I put for example, let's go back to 7, and the row is 1 and the column is 2. This kind of gives us the number 12. It's not 12, but looks like, right? Because I start with the row and the column. Let me open here in Excel. I can see something like something interesting. I did a grid of 10 by how many? 7, 18. But how many columns do I have? I have 10 columns. Now, what is the index of, for example, 64? 64 here is row 6 and column 4. And what if I just append 6 and 4, I get 64. And for example, row 2, column 8 will give me 2, 8, 28. And why this works? Because I have 10, I have a column of size 10. So every time I fill 10, I go to another row. And this is exactly how our digit system works, our decimal system works. What is the number? Let me add here some space. What is the number 18? Is 1 times how many digits do I have for the first position of digit, 10, plus 8. 10 plus 8, 18. So what do I have here? The 1, 2 is 1 times how many elements can I put on my column digit? So 5. Then I add the column digit, the column value, 2. Here, 1 plus 5, 5, plus 2, 7. So if I have, for example, the index of the row is 8 and the column index is 2, I have 8 times 5 plus 2, so 42. And so on. If my column size were, I don't know, 20, and I have, for example, index 12, what is, sorry, it's not 12, 1, 2, what is 1, 2? Meaning row 1 and the column 2 in a 20 size column, it will be 1 times 20 plus 2, 22. And the interesting thing of seeing like this, of course, this looks like an overkill. Why you can see already in the in this diagram, okay, see each row is five columns. Just just multiply the row by 5 or by the size of the column, and then add the index of the column. So why I'm speaking of positional system? Because row and column is like let's say it's like a dimension. Rows would be the tenths and column would be the units, but it's just thinking of dimensions. What is a dimension is something that is independent of the other dimensional. Meaning that if I'm changing my column, I'm not changing row. If I skip column 0 to column 4 to column 2 to column 1, I'm not changing the row. A change in row is independent of a change in column. And actually we can see really graphically this dimensional aspect is that rows, if I change rows, I'm changing vertically. In columns, I'm changing horizontal. And the positional system, it's also the same thing. If I'm changing the units, I'm not changing the tenths, and then if I'm changing the tenths, I'm not changing the units. And why it's interesting seeing things like this is that now we saw a two-dimensional grid, but we can generalize this to a third dimension, a fourth, a fifth, and so on. An n-dimensional grid will be a n digits number, where each digit can go from 0 to the size of this dimensional. So here, rows, the digit is from 0 to 2, and columns is 0 to 4. So what is the maximum index I can have in this two-dimensional is 2, 4. And what will be in one-dimensional? 2 times 5 plus 4. Now, why I keep one-dimensional? Meaning, why I don't just create simply a vector of vector? And if I want three-dimensional, a vector of a vector of a vector. And if I want n-dimensional, a vector of a vector of a vector, and so on. We start to see that if I want n-dimensional, it's going to be a little bit annoying to create vectors of vectors of vectors. I can do this. But why I want one-dimensional container to hold the data? I want to be sure that everything is contiguous. I can ensure this also if I have vectors of vectors. But I want to be sure that everything is contiguous, and I want to be able to expand to n dimensionals. So what do I have here in my grid.h, this vector data? This means the computer implementation, the implementation for the computer is what computers understand, arrays. Vector is kind of an array. It's just a better way of dealing with an array. But as an user, I want to index by the dimensions I'm using. So in a two-dimensional container, I want to give an index of two-dimensional. So this is something it can be a little bit complicated. I hope I made it clearer. But this conversion between two dimensions and one dimension is actually a conversion of levels of abstraction. That's actually why we're creating this grid in the first place. We have our abstraction level of a user that understand two-dimensional containers, either a grid, either a matrix, and we have the level of abstraction of vector. That's already a level of abstraction of an array, but that the computer understands. So we are just doing a translation between this. This is the whole point, actually, of the grid. Okay. All of this because I wanted to explain why we do row times columns, how many columns plus column. I hope it's clear. by the way, if you are following, if you understood what happens in the third dimensional, okay, rows, columns, and I need a third name to address the third dimension. So let's just do dimension 1, dimension 2, dimension 3. I would be the index of dimension 3 times the size of dimension 1 plus times dimension 2 plus the index in dimension 2 times the size of dimension 1 plus the index of dimension 1. Okay, hope it's a little bit clearer. Let's continue. So now we just did our way of accessing the element. By the way, accessing by reference, what does it mean? It means that I can write and read the element. I'm getting a reference to what is inside. A reference means I'm getting a way of, I kind of get the address. It's not a kind of, I get really an alias for this value, so I can read it, I can see what's the value, but I can also write it. So it's a way of saying set and get in the same function, the same method. Why I call at? Because I think it's a good name, and also it's the same thing we use for vector. So it's a name that is already used. Okay, let's continue. Now let's test our grid. I'm going to the main function. I'm going to include IOStream. I'm going to include grid.h. Let's test with a grid of integers. Okay, let's test the same size that we did here, meaning I have 3 rows and 5 columns. Okay, now we are going to display all the elements of the grid. Let's make it bigger here. Yes, I forgot to include vector. So Q1, we see that is this element here. Let's say is equal, I don't know, -6. And I see, okay, I wrote here in the example bad, Q1 is this element here. And I see I wrote to -6. So, okay, our grid is okay. We could say we finished, but let's start by saying here, auto row from 0 to 3, I hard-coded. So one of the things that would be interesting is to get the row size. So let's code this function, this method, row size. We're going to do column size and maybe even total size. Okay, now I can just replace, instead of 3, I can replace by grid row size, and here by grid calls size. By the way, if you want to understand why auto was not working, when I wrote auto row is equal 0, he understands auto as an integer, but row size is giving me a SIST, and the SIST is unsigned long. So if I had left auto, but here I would put unsigned, it would work without warnings. Okay, good. Now, something I would like is to improve a little bit this for loop. I would like to be able to do something like this. For the row in the rows. Now, why I called row size and not rows? I could say just rows because my private is rows with an underscore. I could just write size t rows, return rows. I want to keep rows for something else. And what? I like a lot this syntax. It's kind of a for each syntax that we have in a lot of languages like Python. And I would like to be able to use this. So what I'm going to do is grid.rows will return me a vector that I can iterate from 0 to how many rows. Let me create something, some function. Range, if you know Python, it will be very familiar. So range is going to create a vector of size t. Size t, by the way, is just it's like it's a unsigned long. Why unsigned long? Unsigned because it's from 0 to something. It means we don't have minus negative. We don't have negative values. Why we don't need negative values? Not that range I don't want negative values, but rows and columns, they are always positive. I don't have -3 columns. I will always work with positive numbers. Here I have a vector of size t, a vector of type size t, and of size end. And what I'm going to do is that for 0 to end, I have the value. So res is going to be a vector 0, 1, 2, 3 until end, not included. So really looks like a Python range. Okay, so now grid.rows, what we're going to do. And of course, we're going to do columns also. Okay, let's check it. Not return end, sorry, return res. Again. Okay, so now I can use this syntax. I can use also this one here. Grid.columns. Now this piece of code here, we can put in a function, for example, show grid. Let's put as a template. Why I'm putting the grid as a const reference? Why const? Because I don't need to change the grid. I'm just showing it. So let's show the grid. And now it's not working. And this is something that can be quite annoying with C++ to find, to understand. Because, to be honest, I cannot understand those error messages. I really cannot understand. Passing as this, argument disqualified, discards qualifiers. What is this? I don't understand anything of this thing. But you kind of need to keep in mind that you just put a const here. Meaning that every function, every method of grid needs to be const. Grids calls and grids rows are not const. So let's add const. And by the way, what is const means that I will not change the value. Perfect. Almost perfect. At is not constant. Okay, let's put constant. It's quite easy. Just put const. And we did before, it worked. But now it doesn't work anymore. Why it doesn't work? Because I cannot put const here. This at is not const. What is at? This at is the at of vector. So let's go here. Wait, there is a const reference. So it's const. But there is this one that is not const. So which one is taking it? I need to take out the reference. If I take out the reference, it's taking the const. So, okay, a little bit more complicated to understand, but now it's going to work. But now this one doesn't work because this is trying to change something. I can read, but I cannot write it. I need the reference. So I need this. So now what do? If you remember, in the vector, we have two at, one const, one not. So what I can do is just duplicate one that is not const and one that is const. And now everything works. The issue here is that why we have two ats? If you see, we have overload. Overload means that I can put a different signature of the function for the same name of the function. And it's very practical, but there's something I personally don't like in this case. When you overload, you're typically in a situation that sometimes you need more parameters, sometimes less parameters, or different parameters. For example, if you have a function abs, like for absolute value, in C, in C++, we also have fabs, like for float. You can just do overload. It's just you could not do this in C, so you have fabs, but you could have abs that accepts an integer or it accepts a float, a double. You just overload. But the core of the function is the same. It's taking the absolute value. In this case, at one is by reference, one is not. And what are you doing here? One is doing a get, only get. The other is doing a get and a set. So for me, they're not doing the same thing. So I'm not comfortable using at as an overload here, the same name. So what I'm going to do is here I'm going to write at const. It's maybe an ugly name. If you have a better name, please. Not at const here, sorry. I put in the wrong one. This means that when I write at, I mean the reference. When I write at const, I mean just the get. I'm constant safe. So here is not going to work because now at, I need to put at const. Okay, now it's working. Okay, great. That's it for today. There's a lot of things that we can do to improve this grade. One of the things I want to show next video is how to get neighbors and to implement a structure for indexes. Thank you for watching. See you next video.